Let's be real for a second. Physics, it can feel like this huge, totally uncharted wilderness, right? You've got black holes over here, quantum weirdness over there, and all these equations that look like a different language. It's a lot. But what if we had a map? What if we could see the entire landscape laid out, showing us exactly where we are, where we've been, and all the mysterious places we're trying to get to? Well, today, that's our mission.
Okay, so here it is. Take a good look. Really drink it in. This is our map. And this isn't just some clever diagram. It's like humanity's greatest adventure, all on one page. Everything from the simple physics that lets you toss a baseball to the mind-bending mysteries of dark matter, it's all here. This thing tells a story of pure genius, of shocking discoveries, and of the biggest questions we've ever had the guts to ask. And we're going to explore it together.
Now, before we go venturing out into the wild parts of the map, let's just get our bearings. Where are you in this grand scheme of things? Well, it turns out you're living in a very specific and actually very cozy little neighborhood on this map. And that's exactly where we're going to start our journey.
We're kicking things off in the part of the universe that just makes sense to us. You know, the world of the everyday. It's governed by a set of rules we call classical physics.
And here we are, home sweet home. This section right here covers the physics of our daily lives. Driving a car, water boiling in a pot, the sun rising and setting. It all feels so intuitive, right? And that's because we live it, every single day. This part of our map was drawn up by the original pioneers who first put the world we can see and touch into the language of math.
The absolute bedrock of this classical world is classical mechanics. And when you think of that, you gotta think of Isaac Newton. The man was a giant. His laws explained everything from something as simple as an apple falling from a tree to something as majestic as the planet circling the sun. His work was so powerful that for hundreds of years people honestly thought, well, that's it. Physics is pretty much solved.
Next up in our neighborhood is electromagnetism. A guy named James Clerk Maxwell did something just incredible. He looked at two forces that seemed totally separate, electricity and magnetism, and he proved they were just two sides of the same coin. And the result of that discovery? Whoa! He revealed what light actually is, and in the process, laid the groundwork for, well, basically the entire modern world. Your phone, the internet, the lights in your room, you can thank him for that.
So here's the deal. The classical world is predictable. You push something, it moves. It's intuitive. But as we got into the 20th century, scientists started exploring the far edges of the map, the world of the incredibly fast, the unbelievably massive, and the mind-bogglingly small. And what they found out there was that the old comfortable rules, they didn't just bend, they completely shattered. A revolution was coming.
And that brings us to two massive, game-changing revolutions in thinking that completely redrew our map of reality, taking us into the realms of the very, very big and the very, very small.
Okay, our first trip is going to be to the universe at its most grand. We are heading into the territory mapped out by the one and only Albert Einstein. This is the land of relativity, a place where time itself can slow down and space can literally bend and twist.
Now, here is the absolutely wild idea at the heart of general relativity. Einstein basically said, gravity, it's not a force pulling you down. Instead, he said that huge objects like the sun or the earth actually warp and curve the fabric of space-time around them. So what we feel as gravity is just us rolling along those curves. It was a complete and total reimagining of how the cosmos works.
All right, now we're going to jump to the complete opposite extreme of our map. While Einstein was looking up at the stars, a whole other team of brilliant minds was looking down, deep inside matter itself. So take a deep breath, and welcome to the bizarre and, frankly, wonderful world of quantum physics. Now, our understanding here didn't happen overnight. It was more like climbing down a ladder, going deeper and deeper. First, we figured out the atom existed. Then, we managed to peek inside and understand the nucleus. Then we smashed those apart and found a whole zoo of tiny, fundamental particles. All of that incredible knowledge has been organized into what we now call the Standard Model. It's our best, most rigorously tested theory for how all the particles and forces work at the tiniest scales.
And this, right here, brings us to the single biggest problem, the biggest headache in all of physics today. We have relativity, this beautiful, incredibly successful theory for the very big things. And we have quantum mechanics, another beautiful, incredibly successful theory for the very small things. They are the two pillars of all modern science. The problem? They fundamentally contradict each other. It's like they describe the same universe using two completely different and totally incompatible languages.
And that giant contradiction? Well, it brings us to the final leg of our tour. We're headed to the very edge of the map, to the part where old cartographers would just write, "Here be dragons." This is the frontier of all human knowledge.
Our map gives this place a fittingly dramatic name, the Chasm of Ignorance. I mean, what a name, right? This is the huge, gaping gulf that separates our two greatest theories, relativity and quantum mechanics. This is the place where our current understanding of the universe just stops. It breaks down. And for a scientist, that makes it the most exciting place on the entire map.
This chasm is filled with some of humanity's biggest questions. What is quantum gravity? Physicists are trying to build a bridge across this gap with wild ideas like string theory or loop quantum gravity. And then there are the other elephants in the room. What on earth is dark matter? And what is dark energy? I mean, this stuff seems to make up 95% of the universe, and we have almost no clue what it is. Think about that.
And check out where the map leads us now. Right at the bleeding edge of physics, we bump smack into philosophy. These questions, they stop being just about math. They become about the fundamental nature of reality itself. They force us to ask things like, what is time really? What is consciousness? Do we actually have free will? And the biggest one of all, why? Why is there anything at all? And you know, maybe that's the whole point. Like Albert Einstein said, the most beautiful thing we can experience is the mysterious. It is the source of all true art and science. That mystery, that's what drives us. This whole quest, this exploration of the map, it's one of the most profound and beautiful adventures our species has ever been on. So as you can see, this map is far from finished. And here's the really fascinating part. Every time we fill in a new little piece of it, the coastline of our knowledge, that border with the great unknown, it actually gets longer. There's always more to explore. And so, as we stand here looking out at that vast, mysterious ocean of ignorance, we're left with the most exciting question there is. What are we going to discover next?